Right, first things first, we start with a couple of big math shout outs. Some of you have particularly requested these. So, Ron and Liv, Booyakasha, that's your big math shout out. But seriously, what are we going to do in this lesson, the second of the lessons this week? We've been looking at how if you have two shapes which are similar, if you know how one pair of lengths is related, that scale factor tells you how all the corresponding lengths are related. So in this case here, we've got a scale factor of 3. This side is trebled to get that one, and this one is trebled to get that one. And the same way we'd find that the hypotenuse is trebled to get that one. We could quite sensibly be talking about a scale factor for the lengths. What we want to look at in this lesson is how does that relate to what happens between the two areas. And I've got to be careful now. I've got to turn off the highlighter and then I find it works. So for example, to illustrate, the areas are not multiplied by 3 in this case. That second triangle is not 3 times as big unless we're specific that we're talking about lengths. Can we show that? The area of the first triangle, half base times height, is 3 centimeters squared. You may want quickly to work out the area of the second one, half base times height, 27 centimeters squared. Multiplying the length, the base by 3, and the height by 3 has effectively increased it by 3 times and 3 times, 9 times. Increase the lengths by a factor of 3. We increase the areas by a factor of 3. What we find is whatever you multiply the lengths by, let's call that k, you will square that to get what you multiply the areas by. Okay? If we know the scale factor for lengths, we can square that to get the scale factor for areas. Right, for area, the relationship is squaring. For volume, the relationship is cubing. Can we illustrate that relatively easily? Yeah. Before we look at the diagram in the middle, think about this cube. If I make all the lengths 1, then the area is the area of the 6 squares that make up the cube. So the area will be 6 times 1 squared, 6 times 1 times 1, 6. And the volume of something that's 1 by 1 by 1 will be 1 times 1 times 1, 1. A 1 centimetre cube has a volume of 1 centimetres cube. Well, let's think what happens if we take that cube and we multiply each length by k. So if we now call the lengths k, the area will be 6 lots of those k squareds. Okay, so the area goes from being 6 to 6 times k squared. And the volume, k times k times k, is k cubed. Okay, if we multiply the lengths by a number, we multiply the area by that number twice, and we multiply the volume by that number 3 times. Okay, and if we multiply by something twice repeatedly, we're multiplying by that number squared, etc. Right, this diagram is going to appear at the end when we do the questions again, but in general, if you have a length scale factor, we can go to an area scale factor by squaring. If you have an area scale factor, we can go to the length scale factor by square rooting. If we have the length scale factor, we can go to the volume scale factor by cubing. If we have the volume scale factor, we can get to a length one by cube rooting. You might wonder why I put it in this ridiculous cycle. Well, the best questions, you know what I mean by best, I mean the hardest ones. The best ones will be where they give you area information and you have to get all the way around to volume information. Or the best ones might be where they give you the volume information and you have to go all the way around to the squared the area information. Now if you follow that route round, area to length, length to volume, and let's see if we've got a couple of questions that ask us to do that. So again, I'm just going to turn the highlighter off so I can do the animation. So same information at the top of the page. If we know for area, scale factor is squared, volume, the scale factor for length is squared. So for example, if we know a shape is enlarged by a scale factor of 5, if all the lengths are multiplied by 5, and we know the original area, can we find the area of the second shape? If the lengths are multiplied by 5, the areas are multiplied by 5 squared. So an area of 3 meters squared becomes 75 meters squared. This is that bit about length and area scale factors. The second one, shape A is enlarged to form shape B. The surface area is 30 and the surface area of B is 120. Right, so that's been multiplied by 4. Okay, so what do we know here? This time we have been told that the areas have been multiplied by 4. How do we go from area scale factor back to the length scale factor? You square root, exactly, well done. Square root of 4 is 2. So the lengths have been doubled. Just check whether you're going to a bigger to a smaller shape. In this case it was A has length 5, what are the lengths of B? And it was quite clear that A was the smaller shape. So what's really good to do, this little table of the values here is quite a good one, isn't it? Or a diagram, label a diagram. Right. Same fact at the top again. Doesn't hurt to keep reiterating that, doesn't it? Or the diagram which is going to appear at the end. So let's see what information we've got this time. A is enlarged to give B. We've got the area of A and the area of a larger shape. A is smaller, B is bigger. The volume of A, right, so we don't have anything about the lengths. And this is where we're going to go from the, what have we got? We've got two areas, so we're going to go from area to length to volume is what we're going to do on this one. Sorry, the dog just went out the door, so I'm just wondering if it's going to bark. Okay, so I'm going to turn the highlighter off. What information do we have? We have the area information. Areas have been multiplied by 9. We need the length information before we then get the volume information. So from area to length, square root. From length to volume, cube. 27 times 80 is roughly 2,160. Okay. Right, so that's one of the very harder ones. So on this next page, we've got two shapes are mathematically similar. Surface area of A is 20. What's the surface area of B? Are we missing some information? No, we're not missing information. Let's have a look what we've got. We've got the volume information. So we can work out, perhaps before I reveal at the end, you could be thinking what order we're going to do things in. Okay? We know the scale factor for the volumes. So from the volume information, we're going to work out the length information. Oh, is that mirrored it the wrong way around? No, that's the right way around, isn't it? Well, length information, and then we're going to work out the volume information. So it's area to length to volume. Okay? And when we come back, I think Alex and Izzy, you said you'd synchronize some dances for us for that, can't you? So maybe you can be thinking about how we do the area to length to volume information. What I'd like is all of my maths group being the length people, and we can do that to the other groups, can't we? Okay, so the other groups, this is what we think of you, because we're the length people. Okay, sorry, keep it serious. Right, if I remove this box then, what have we got? So the order would be, we knew the area information, the volume information, 64. So you cube root that to get 4, which you square to give 16. 16 20s are 320. That's an example of the best ones, okay? So on this final page, we want you to do from exercise 12E, 1A and C, 2A, B and D, 4, 8 and 13. As always, if you get stuck, email your teachers. But this is what I would use. Comes back to, you need to, at some point to know the scale factor for the lengths. If you know the length scale factor at the beginning, you're laughing, because from length you can get to area, and length you can get to volume. If it's area or volume you're starting with, you go from area to length or volume to length. And then, like we've already said, you can then get from area to volume and volume to area. All the best with that. And don't forget, if you want to shout out, do what Ron and Liv did. Email. Take care.